Hi everyone, my name is Daniel Temboy and I want to teach you about Bragg's or Lou condition. Probably you guys are wondering, what is this Bragg? But I'm going to explain for you in a few. Has anyone of you ever wondered how people know the structure of a protein?
No. How do they? That's a very interesting.
So, how they find out the structure of a protein, they use another technique called X-ray crystallography. What they do, they make a protein into crystals, and then once it's formed into crystal, it's gonna be displayed like in a plane. For example, every plane you see here has crystals of protein. So, and this one is the source, and usually the light that shines, for example, how we see objects, for example, how I'm gonna be able to see this mobile phone is the light's gonna strike this one and reflect, and there's a lens in my eye that will enable me to see it. But unfortunately, the size the space between two atoms in a protein is too small, like ordinary light cannot enable us to see. So the rays of light that we're gonna use here are called X-ray lights. So what they do, once a protein is formed into crystal, so let me say the steps in making a protein. We first make it into a crystal. Second, once it's made into a crystal, it will have these planes. These, like, just say in a crystal, and these planes have atoms of a protein. So just imagine this like more than, let's say, a million planes in one crystal. All of them have different atoms. So how this happens is that they will shine X-rays. These are X-rays according. They will shine X-rays into this plane, and just like our eyes have something like they're gonna capture those images, they'll have something like a board that once these rays comes in, it's gonna come outside and it's gonna be trapped here. So remember, X-rays are waves, and one feature of waves that they go in, they have a crest and a trough. So this is the crest, this is a trough. So let's say this is a wave from this plane here above, and another ray comes into this plane. So let's say it goes like this. So what happens when a crest of one wave meets with a trough of another wave?
It becomes a line.
Very good. It forms a line, like it's gonna interfere. This crest and this trough will kind of cancel each other, and will form a line. So this one wouldn't be helpful because we won't be able to get interference above. What we want, excuse my rhythm. So what we want, all the waves that are coming here, they should interfere constructively. Like, for example, they should all go like this, such in a way that the crest meet a crest and the trough meets a trough. So at the end, we'll have something like this. For example, these are two waves that have interfered constructively. The resulting wave will have the amplitude as a result of the summation of these. So the Bragg or Lou condition gives us a funny equation here. It's called 1 over d is equals to 2 sine theta. This angle is the angle at which the reflected ray will be leaving here, and this d is the distance between two planes. So for these X-ray waves to live in such a way that they're gonna interfere constructively, they'll have to live at this angle theta, given this d. Let's say this d is 2, so we'll have to find out which angle theta that it will have to balance to come out so that it can interfere constructively. Any questions?
Wow.
So remember, we can't only like get spots enough from like two waves. It has to be like million waves so that it can form a darker spot. So one advantage of this condition is like it concentrates many waves to form a spot that is so dark, and later on another steps can be followed and this crystal structure of a protein can be known. Thank you so much, guys.
Thank you. That was very, very interesting to learn.
All right.